ஜி லைவ் வருதா?
இருங்க ஜி ஒரு நிமிஷம்.
வந்துருச்சு.
வந்துச்சா? சமதி
இப்போ உங்களோட இது பண்ணுங்க.
இது வேலிடிட்டி ஈவென்ட்.
உங்களோட அந்த ஷேர் ஸ்கிரீன் இருக்குல்ல,
என்ன ஜி வேலிடிட்டி ஈவென்ட்ல போய் லைவ் கொடுத்து வச்சிருக்கீங்க? வேலிடிட்டி ஈவென்ட்ல போய் லைவ் கொடுத்துருக்கீங்க ஜி.
வேலிடிட்டி
இப்ப கொடுத்துருக்கீங்க பாருங்க. நீங்க கொடுத்த லிங்க்ல போய் கொடுத்துருக்கீங்க.
புரியல.
நீங்க கொடுத்த லிங்க்லயே போய் கொடுத்துருக்கீங்க?
ஆமா ஜி, அதுல தான் கொடுத்துருக்கேன்.
ஒரு நிமிஷம் இருங்க. அதுல வரலையே ஜி. இன்னும் 26 மினிட்ஸ்னு வருது அதுல.
ஆமா ஜி, 26 மினிட்ஸ் தான். 4:55 தானே.
அப்பதான் உள்ள வருமா? அது வரைக்கும் இப்படிதான் இருக்குமா?
ஆமா. இப்ப என்ன மாத்தவா?
மாத்தாதீங்க.
4:56 தானா லைவ் ஆயிடும்.
அப்படிங்களா? ஆயிடும்ல.
அது வரைக்கும் இப்ப கவனம் கூட வச்சுக்கோங்க. இல்ல, அதுவே ஆயிடும்.
ஆனா அது உள்ள பாத்தீங்கன்னா URSAGO சொல்யூஷன் போன வாரம் வந்து லைவ் வருது. எங்க ஜி? ஒரு நிமிஷம் இருங்க. நீங்க URSAGO பாத்தீங்கன்னு வச்சுங்க, இந்த இது லைவ் வருது.
என்ன வருது?
வேலிடிட்டில வந்து வருது. புரியல. TVLC ஆன்லைன் மான்சூன் இன்டர்ன்ஷிப் வேலிடிட்டி ஈவென்ட்ல வருது லைவ் இப்போ.
இல்ல ஜி, MC ஸ்டார் சென்னை சாப்டர் லெக்சர் சீரிஸ் 2 இதானே URL நான் பாக்குறேன். அதுதான் ஜி.
அனுப்புறேன் பாருங்க. இந்த URL கூட உங்களுக்கு அனுப்புறேன் பாருங்க.
இல்ல, இது கஸ்டம் URL. நீங்க வந்து அவங்களுக்கு கொடுத்த URL எல்லாரும் வருவாங்க. கரெக்ட்டா?
அது ஒண்ணும் பிரச்சனை இல்ல.
அது ஒண்ணும் பிரச்சனை இல்ல. இது வந்து நீங்க வந்து இது கிளிக் பண்ணி பாத்தீங்கன்னா அதுல வருது.
இது இப்போ உங்களுக்கு அனுப்பிச்சிருக்கேன் பாருங்க.
ஆமா, இதுதான்.
அது உள்ள போனா அந்த டைம் ரன் ஆயிட்டு இருக்கு. இன்னும் வரல.
24 மினிட்ஸ் வருது.
ஓ, அப்ப கரெக்ட்டா வந்துரும் அதுக்குள்ள.
அதுக்குள்ளார தான் வரும் அது. இப்போ வந்து நீங்க என்ன பேசிட்டு இருக்கோமோ இது எல்லாமே நமக்குள்ளார இருக்கும் ரெக்கார்டிங்ல. இல்லையே,
இன்னொன்னு URSAGOலயே லைவ்னு வந்திருக்கு.
ஜி எங்க ஜி வரும்? இதுதான் ஜி லைவ்னு ஓடும். ஆனா யாருக்கும் தெரியாது.
அப்படியே சொல்றீங்க? ஒரே நிமிஷம் இருங்க.
ஆமா,
இந்த லிங்க் அனுப்புறேன் பாருங்க.
யாருக்கும் தெரியாது.
பாருங்க, இருங்க.
வருதா?
இந்த இருங்க. இப்போ
நிறைய பைப்லைங்க அதுக்குள்ளார வந்துட்டானுங்க. ஸ்டார்ட் பண்ணானே
பாத்தங்க. இது இஸ்ரோட டெண்டன்ட் அப்படி. இப்போ ஒரு லிங்க் அனுப்பிச்சிருங்க பாருங்க. அந்த லிங்க் உள்ள போய் பாருங்க.
ஜி நம்மளோடது தான் ஜி அது.
இல்ல ஜி,
கரெக்டா பாருங்க ஜி. நம்ம அனுப்பிச்சிருக்கோம்ல பழசு.
அனுப்பிச்சிருக்கேன் பாருங்க.
அதுதான் இப்ப அனுப்பிச்சதுதான். இதே சேம் லிங்க் தான்.
இப்போ நீங்க இன்னும் பார்க்கவே இல்ல.
நான் பார்த்துட்டேன். இங்க பாருங்க.
லாஸ்ட் வேர்ட் MYGன்னு வருது. இதுல PKA வருது.
PWK வருதா?
இன்னொன்னு வருது பாருங்க. இன்னொன்னு அனுப்பிச்சிருக்கேன் பாருங்க இந்த லிங்க்குக்கு கீழ.
இதுல என்ன வருது?
இதுலதான் வந்து இப்போ நம்ம பேசுறதெல்லாம் அதுல வந்துகிட்டு இருக்காங்க.
அப்படி IG என்ன பாலா அப்படின்னு செந்தில்குமார் போட்டிருக்காரு. இல்ல ஜி, அது உங்களுக்கு பழசு இது இருக்கும். ஸ்டார்டட் ஸ்ட்ரீமிங் 3 minutes ago அப்படின்னு இருக்கா? ஆட்டோமேட்டிக்கா 3 minutes கழிச்சு இதுவாயிடும் ஆக்சுவலா.
ஓகே, நீங்க கொடுத்த லிங்க்ல வந்துரும்ல. அப்படி இல்லனா நீங்க தான் உள்ள வந்துறீங்க பண்றீங்க.
இல்ல ஓடி போயிடாதீங்க. நான் செக் பண்ணி இந்த டைம்க்கே லைவ் பண்ணி கொடுத்துறேன். தேவையில்லாம MCலயே கொடுத்துறேன். எந்த டைமுக்கு கொடுக்க? இப்பயே கொடுத்துருவா? 4:32 கொடுத்துறேன். ஓகே.
जी 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 கேக்குதா? जी பாலமுருகன் பாலமுருகன் பாலா
ஜி
ஓகே இப்போ now it is live right?
ஜி இப்ப லைவா இருக்கு.
இல்லையே லைவ் in 60 seconds ன்னு வந்திருக்கு.
இல்ல இப்ப பாருங்க லைவ்ல தான் இருக்கு. இட்ஸ் லைவ் ரா.
சேம் லிங்க்
லைவ்ல தான் ஜி இருக்கு.
எனக்கு லைவ் in 60 seconds ன்னு வருது.
ஆமா லைவ்ல தான் இருக்கு பாருங்க. செக் பண்ணுங்க. நான் இப்போ இந்த சும்மா ஒரு வீடியோ ஷேர் பண்றேன்.
ஷேர் பண்ணுங்க.
செந்தில் ஃப்ரீயா இருக்காரு.
போட்டிங்களா லைவ்?
மியூசிக் வருதா பாருங்க.
இதுல வரல போல.
அப்படியா?
எங்க ஒரு நிமிஷம். வருது மியூசிக் வருது.
ஓகே அவ்வளவுதான். அதுதான் நான் இப்ப ஸ்டாப் பண்ணிட்டேன். நீங்க அப்படியே பாத்துக்கிடுங்க. சரியா?
இப்ப எப்படி இது வீடியோ கொடுக்கறது? அந்த ஷேர் பண்றது
நீங்க ஷேரிங் கொடுங்க. உங்களோட யூடியூப் போச்சு இல்ல, இப்ப ஷேரிங்ல போங்க.
போன்லயேவா?
போன்லயே.
போன்ல எப்படி பண்றது?
ஷேரிங் போங்க ஜி. ஷேர் ஸ்கிரீன்.
ஓகே ஷேர் ஸ்கிரீன்.
அவ்வளவுதான். ஏற்கனவே அங்க இதுவா இருக்கும் பாருங்க, அதுல இருந்து கொடுத்துருங்க.
இல்லையா ஷேர் ஸ்கிரீன் இஸ் நாட் எனேபிள்ட்.
அப்படியா? உங்களுக்கு தான் ஹோஸ்ட் இருக்கு இப்போ.
போன்லயா இல்ல?
போன்ல தான். லேப்டாப்ல இருக்கீங்க இப்போ?
இல்ல இன்னும் லேப்டாப்ல வரல.
சரி. போன்லயே நீங்க ஷேர் ஸ்கிரீன் கொடுங்க. ஷேர் போயிருங்க.
போக மாட்டேது ஷேர்.
ஜஸ்ட் ஷேர் போங்க ஜி. வரல. சரி செந்திலுக்கு நான் அடிச்சிட்டு ஷேர் பண்ண சொல்றேன். செந்திலுக்கு ஷேர் பண்ண சொல்றேன். லேப்டாப்ல இருந்தீங்கன்னா நான் இது பண்றேன். ஒரு நிமிஷம் செந்தில்கிட்ட சொல்றேன். ஒரு நிமிஷம்.
Sandil sir. Sandil sir.
ఎక్కడ కనిపించినాడు?
இங்க எப்படி தெரியுது அங்க எப்படி தெரியுமா? அது கீழே ஒரு நோட் புக் வச்சுக்கிறீங்களா? லேப்டாப் கீழே தூக்கி வச்சுக்கிறீங்களா? ஃபுல் ஸ்கிரீன் வரும். இது ஹெட்ஃபோன். ஆமா, ஹெட்ஃபோன் போல யூஸ் பண்ணீங்க.
Sir, you can unmute and check, sir. Your video is okay, sir, but audio we have to check.
Hello, this is test call. Is it okay?
Yes, sir. We can hear, sir.
Okay, Gupta seems to be having some problem, but I don't know what exactly is the issue. Okay, we'll check up. He's trying again.
Okay, sir.
Okay, so I am ready.
Yes, sir.
Right.
எல்லாம் பண்ணிட்டீங்களா? ஜிமெயில் எல்லாம் போட்டு எல்லாம் பாத்துட்டீங்களா?
Participants only 19 participants so far.
ஆஃப் பண்ணிட்டீங்களா?
சார்ஜ் போடணும் இல்லைன்னா இதாயிரும். அதான் எக்ஸ்பிரஷன் போடுறது நீ தடவை எங்க
அந்த சேர் தெரியுமா?
Angana 829 842
இந்த சேர் தெரியுமா? பின்னாடி சேர் தெரியுமா? தெரியும்னா அந்த பக்கம் வச்சுருக்கேன். எப்படி சேர் அது சேர் இல்லை.
Yes, Corona. Hmm? Yeah?
Gokul? Gokul?
Yes.
Yes, sir.
Gupta ji joined?
Sir, I am here.
Ah, yes, sir. Okay, welcome, Gupta ji.
Thank you.
Yes, sir. Welcome, sir. I think you can switch on your video also, sir.
I am not able to see you or see anything.
Okay.
Ah,
Sir, you
yes.
have to switch on your video,
I
sir.
saw you for a second.
Gupta ji, you are able to see me?
Yes, sir. We can see you, sir.
But I am not able to see Gupta ji.
Right, sir. No problem. Yeah, I can see you now. Can you see me?
Okay.
इसकी जरूरत नहीं है.
I am not able to see you, Gupta ji. Second later.
அப்படிதான் வச்சுக்கணும்.
அது வந்துருச்சா? வந்துருச்சு.
வந்துச்சா?
பாரு, வந்துருச்சா?
வந்துச்சு.
पीछे मत आओ।
ये नहीं अंदर की इसको करना है, बाहर करना है।
करना पाठक
You want to tea, coffee? पॉइंट यहाँ पे भी है। Okay.
Thank you.
వచ్చి చేసి స్నానాలు చేసుకొని అది అదే వచ్చి దాంట్లో నిండి దాంట్లో అది ఇంట్లో ఎక్కువ ఉన్నాయి సామాన్లు కానీ ఇప్పుడే చెప్తాను.
Sir, Gupta sir, can you check your PPT, sir? We have made a post.
Yeah.
You can just share it and check, sir. Like PPT.
Sir, I am here and I've been speaking, but I can see sometimes some person, some other person and all that. I'm not continuously able to see.
But you have any PPT, sir?
Right now, no, I am speaking from, there is a PC on which I am connected to. Yeah, now I can see some person.
Yes, sir. I think there, I think we need to have your view.
Anji?
I think in the view, speaker view, or you have to see that, I think. In the,
Where is? कहाँ गया? View में लगाओ.
This is
View. वो चला गया भी. View.
View is not.
Full screen, yeah. No problem.
since I think many of them are not in video mode, I think you can only see the screen, sir. Yeah, now we can see your screen, sir. I think.
I can see you. Yeah, yeah, you can see me.
Yes, sir.
But Colonel Pathak name is coming, not.
Yeah, yeah. Yes, sir.
View पे कर दो ना. View.
You have a PPT, sir, so that you can share the screen and check it. Your PPT is visible.
Okay.
Unmute. Yeah, now I can see you.
Yes, sir.
Can you see me?
Yeah, sir. We can see you, sir.
Right.
Gokul?
Yeah.
Okay, can you listen to me and hear?
I can see now and I can. Are you able to hear me?
Yes, sir. We can hear, sir. Yeah, I can hear you.
You're able to see me?
Yeah, you are able. You are audible as well as visible.
Okay, thank you.
Thank you, sir. How are you, sir? Gupta, sir, how are you? I am Kanakraj, sir.
Perfect.
Yeah.
Sir, Gupta, sir, you have any PPT, sir, to present, or like only you are going to talk, sir?
No, whatever you say, I'm ready to present.
No, if PPT is there, I think we need to check. You can screen share. No, if it is already prepared, I think we need to check. Like you have to share the screen and you have to see, sir. The PPT is displayed to the people. Rohan, welcome, Rohan.
Hi, good evening, Gokul. How are you?
Yeah, I'm fine. You can also, I think you can come on video mode and you can check it out. You have any PPT, Rohan?
Yeah, I mean, I will share. I will present after maybe Dr. Gupta's presentation.
Sure. Yeah. Okay, your audio is perfect. So that maybe when you're starting, we will check your video also. No problem.
Definitely.
Sangeeta ma'am.
Yeah.
Ma'am, Sangeeta ma'am, are you there? Ashwini? Ma'am, you yourself can unmute, ma'am. Your co-host only. Ma'am, நீங்களே unmute பண்ணலாம்.
Okay.
Yeah. Ma'am, Ashwini is there, I think. Ashwini is ready, ma'am.
Some network problems.
She has joined.
There. If she is not there, I'll take up.
No, she has joined here.
Yeah, her net is fluctuating.
Okay, so you will be starting. No issues, now, ma'am.
If she is not there, I'll start.
Sir,
నెట్ లేదు, నెట్ రెడ్ వచ్చేసింది. పాపం అశ్విని మోడరేటర్ చీర కట్టుకుని ఉంటది.
సార్ సురేష్ బాబు సార్, you are unmute, sir. Sir, Ranganathan sir, you can unmute, sir. If you're ready, we can start, I think.
Yeah, I am ready. You are able to hear?
Yeah, sir, we can see you, sir. Yeah, we can hear you, but no video is there.
Me?
Video. Yes, sir, we can see the video. Yeah.
Google?
Yes, sir, we can see you and we can hear you, sir.
Sir, I have one complaint that my name is not coming there. Colonel Pathak is coming.
Video is not there.
Sir, I think you yourself can rename it, sir. Maybe I'll check it out. I think only you can rename, sir.
Rename.
Hello?
Just rename. Right, A.N. Gupta. Dr. A.N. Gupta. इसको rename करो.
Google.
Sir.
A.N. Gupta.
Yes, sir, now we can hear you, sir. I think it got stuck up.
Okay. Okay. I think the
Yes,
name is
Kavita,
given
you
by
can
us.
rename. Yeah, it has come, sir. Yeah, your name is come. Yeah.
This computer was used by Colonel Patakar earlier.
Okay.
For some talk.
Sir, we can start, sir.
Yeah, we can start.
Ashwini.
Gokul, by chance, Dr. Chakravarti and Dr. Ramakrishnan joined or no?
No, sir. Ramakrishna, sir, we asked him. I think he is in some review meeting, it seems. He may join lately, like that, he said.
Okay. But, Chakravarti also?
Sir, also, we are friends, sir. Sir may join like that, I think, sir.
What is it?
He may join, sir. Maybe he said you can start, I'll join.
Okay, from IACH, Dr. Ghosh joined.
That I'm not knowing, sir.
Somebody is unmuting.
Yeah. Okay, so they may join, I think, sir. We have already sent the invitation. So.
Okay.
Maybe Ashwini or ma'am Sangeeta, you can start if Ashwini could not able to make it, I think.
Yeah, now she joined.
5:30.
Ashwini, are you there?
Yes, ma'am, I'm there. Am I audible, ma'am?
Yeah,
Yes.
audible.
Yes, Ashwini, you can start. Yeah, we can start, I feel.
Sir, welcome and a very good evening to one and all. MC Shar Chennai chapter is once again back to you with the second webinar in the series. I am glad to be a part of it. We'd like to thank all the participants of our first webinar for the overwhelming response, which encouraged us to conduct the second webinar. Now, I humbly welcome Chairman, Vice Chairman, MC Shar Chennai chapter, our today's speakers, Chairman IACH Sriharikota Regional Center, all executive members, organized.
Hello.
I think someone else can start. Her voice is breaking.
Hello.
Ma'am, yes, ma'am, you proceed, ma'am.
Okay.
I think our network is.
Yeah, who has got continuous mode of networking, they only can start.
Okay. Yeah, we'll join. I think some network problem with her. So I humbly welcome Chairman, Vice Chairman, MC Shar Chennai chapter, our today's speakers, Chairman IACH Sriharikota Regional Center, all executive members, organizers, and all the participants online on Zoom as well as on YouTube. Today we have two eminent speakers with us to share their knowledge and expertise in their exploring the potential of Indian private aerospace industries. We are honored today to have them with us today. So I request now Sri P. Kanagaraju, Vice Chairman, MC Shar Chennai Chapter and Group Director System Reliability, Sriharikota Shar Center to formally welcome all of you. He is versatile chemical engineer and an expert in rocket propellant technology. Sir, please say a few words.
Yeah, thank you, madam. Sri Ranganathan, Chairman, MC Shar Chennai Chapter. Dr. A.N. Gupta, Chairman and Managing Director, Premier Explosives Limited, one of the major explosives industry in the Indian private sector, and today's Honourable Speaker, Sri R.M. Ganapati, Chief Executive Officer and Chief Technology Officer, Valedictory Aerospace Private Limited, a leading startup in aerospace in India, wise to build rockets, office bearers and members of High Energy Material Society of India, Shar Chennai Chapter, office bearers and members of Indian Institute of Chemical Engineers, Shar Sriharikota Regional Center, respected scientific community of Shar, respected academic community of aerospace and chemical engineering, respected student community of aerospace and chemical engineering. Welcome, a grand welcome to all of you to this present webinar. The organizers selected a theme, exploring the potentials of Indian private aerospace and propulsion industry. We carefully selected this one to bring both the people together. Generally, we see many special economic zones on aerospace, but many industries work for only jet engines, helicopters, etc., etc. But very few on rocket engineering. Maybe zero. Once However, once Indian government agreed for the entry of private sector into the rocketry, the lineup started. Whereas airplanes and helicopters do not require many chemical engineers, rocketry is overwhelmingly in want of chemical engineers. Once we destined to shift our attention from air to support us, that is aerospace propulsion, then chemicals come into our rescue, and hence chemical engineers follow. Where chemicals are there chemical engineers are there. Hence, we organizers try to bring the space propulsion engineers and chemical engineers to a common dais. SJC SHAR has taken a lead for bringing these two specialists together. This webinar is a step towards this. Today, as a part of our goal, we have two distinguished speakers from Indian private sector who are going to speak on flares, a class of chemicals for defense requirements, and two, rocket construction, a journey with ISRO. Let us invite the speakers. Let us invite them. Let us listen to them carefully. Thank you. Thank you, madam.
Thank you for the warm welcome, sir. Now I request Sri Ranganathan, Satish Dhawan Professor, and our beloved Chairman, MC Shah Chennai Chapter, to give a presidential address. He is an expert in solid and liquid propulsion systems. He played a pivotal role in producing S1 world-class solid propellant boosters for many prestigious launch. He was instrumental in establishing many critical facilities at SDSC Shar, Sriharikota. Welcome, sir.
Yes, sir, you can start, sir.
Ranganathan, sir, you can give a presidential address.
Good afternoon, my dear friends, especially Dr. N. Gupta ji, the Chairman and Managing Director of Premier Explosives Limited, with whom we have a long-standing relationship on our SHAR. And I also welcome Rohan M. Ganapati, CEO and CTO of Beltrex Limited, who is in the aerospace in recent time. Sri Kangaraju, my colleague, and all the office bearers, executives, and members of MC, Chennai Sriharikota chapter, and students, all the participants from cutting across the various curriculums and the various fields. I again join Sangeeta in welcoming all of you. It's indeed a great pleasure for me to be in this webinar. And actually, our MC, High Energy Material Society of India, has been doing quite a good work in promoting high energy materials and its ultimate use to a common man and nation. And now I feel that the MC has to play a much wider role, especially in the past few years. If you take, India is allowed to go in for expanding its wings, especially the defense expenditures. If you just look at the defense budget of to Ministry of Defense is about 15.49% of the total budget outlay, and it's about 62 billion US dollars, and it's about 4 lakh crores. So 4 lakh crores is going into defense, and 1/3 of the capital expenditure is 1.3 lakhs is going into mainly for the procurement of capital items for defense, out of which 2/3 of that, nearly about 80,000 crores, is going for import items, mainly missiles and related things, explosives, ammunitions, warfare equipment, all such things. Nearly 80,000 crore is available for these high energy materials, especially import items, though the balance is catered by the Indian industries. And ISRO budget is about 13,000 crores this year. So now, all of you must be knowing that the government of India has taken up privatization of Indian space program, and the privatization or indigenization of various defense equipments. In space, Indian national space promotion in space is available, and authorization is in place now. So the importance of government of India is that we should make everything India. Make in India is the very program of our defense sectors. Where the energy materials is one of the most participant. If you see the India just military in the world, and we spend the 6th largest spender of for our 30% of the total budget is going for the defense, and Make in India program is in place, and our MC has to play a very vital role in addition to our CII and other things. So it is imperative and necessity that our MC awareness and more education and going to colleges, industries, and industrial partners for various institutions, so that we are geared up to meet the Make in India program. Our focusing effort is increasing in the indigenization of defense manufacturing and on related items. The opening up of the defense sector for private sector participation is helping all the foreign original equipment manufacturers to start in partnership with our own Indian industries and leverage the opportunities in domestic and global markets. Penetration come blast, that's called PCB, and thermobar, TB, ammunition specifically are to be done indigenously, and in addition to our light combat aircraft, helicopter, and such things. So if you take, I was talking about 80,000 crores is available for import substitution and for Make in India program. At least if you take even 15%, it comes to more than 10,000 crores is available for our explosive related thing, where the high energy material has to play a major role. And it's not only government of India is talking about this indigenization or Make in India, but recently the Defense Acquisition Council called DAC, which comes under Ministry of Defense, has cleared nearly about 80,000 crore of indigenous investment to make the Make in India program. I also bring to the notice of this MC chapter and the participants that as recent as yesterday, 27th November, the Ministry of Defence organized a webinar on Indian defence industry global outreach for collaboration for partnership through webinar and displays. Say that shows clearly that. So now there are two impetus. One is that we have to make our own defense equipments. Hitherto we have been importing. Not only that, we don't get content with that. We want to export a defense item to the abroad. So and ISRO is on the privatization mode. Even I vaguely remember that or recollect that some private people also is playing that. So this opens up a huge potential for all the related works. I foresee this. So I think CII and all our Indian curriculum, academia, and it will be a flourishing field in this. With this address, I conclude my address. Thank you very much. So I conclude. Please go ahead.
Thank you, sir. Thank you for your wonderful speech and the up-to-date technical for. It's my privilege to welcome our first speaker to the stage now. It's my honor to welcome Mr. Sri A.N. Chairman Managing Director, Premier Explosives Limited. He has earned his master's in mining engineering, and he has developed a penchant for learning and R&D. He is actively involved himself in product development projects of defense and new products and processes. He is a recipient of Pickering and ISM medal from Indian School of Mines, Dhanbad, and gold medalist from Mining Geological and Metallurgical Institute of India. He is a member of Society of Explosive Engineers, USA, and was chairman of Explosives Development Council constituted by Government of India, and chairman of Explosives Manufacturing Association of India. He has been given Asia Pacific Entrepreneurship Award in 2015 in the Outstanding category. He has authored various articles about high energy materials, including scaling up of CL20 production to pilot plant scale, presented at the proceedings of National Symposium on Trends in Explosive Technology. He has been conferred Doctor of Science by Gulbarga University in recognition of his rare distinction and distinguished contribution to the field of science and technology. With this small intro, I welcome Honorable Speaker to stage. Please welcome, sir.
Thank you very much, and good afternoon. This webinar sometimes is going very low on the voice, sometimes going very low on the video. So I don't know how much you will be able to understand what I have to say. But it's a very small presentation which I make. And I distinguished senior officers of ISRO and senior officers of MC. I welcome all of you. And see, there had been a lot of impetus on the presently manufactured defense equipment within the country. The new DAP, which gives a negative list of equipment which cannot be imported directly or indirectly there, and the stress on Atmanirbhar and vocal for local, and presently the emphasis on the export of indigenous material, that is certainly very, very encouraging for private sector players like us, and we are very enthused about it. But how long and how far we can go, that only future will tell us. My present day topic is on flares, and these are the flares which were imported by the country from Bulgaria or from all the European countries. We started making these last year, and we are continuously making, and we are happy that we have got a repeat order of making and using these flares for the Indian Army as well as by Indian Air Force. The flares are a countermeasure used to confuse, deflect a heat-seeking missile during a conflict. This conflict could be anything, can be on small scale, or it could be war. The heat-seeking missile is normally fired at an enemy aircraft and gets locked in on the heat produced by the exhaust of the aircraft engine. The flares are basically burning at a temperature very close to or higher than the aircraft engine. And when a series of these are fired by the airplane, the incoming missile, which is already locked on to some heat produced by the engine, get confused between the flares as well as and the engine. And there is a possibility that the aircraft can escape the heat-seeking missile. And there is a possibility that our aircraft can maneuver and get out of the way of the incoming missile, which is fired at one of the flares. And the flares, there is no harm done, because these are something which have been surveyed by our aircraft. There are two types of flares. One is a conventional flare. These are simply a composition of MTV, where here M stands for magnesium, T stands for Teflon, and V is a Python. The magnesium is a fuel. It burns vigorously at high temperature. Teflon acts as an oxidizer, and Python is a fuel cum binder. The ratio is chosen depending upon the characteristics of the enemy aircraft which fires the missile and the exhaust characteristic of the aircraft trying to escape. Also, it depends upon the seeker used by the missile which is coming on to kill the aircraft. The type of seeker used in the missile is also considered. The old generation missiles used a single frequency seeker. But after this invent of the seekers, of the flares, the missiles are using a two frequency seekers. One to distinguish between the flare as well as the aircraft. The type of seeker many times has a double frequency to distinguish between the exhaust of the flare and the flares to the aircraft. The flares to deceive such a seeker burn at two different frequencies and at two different temperatures. The first one is higher than the temperature of exhaust fumes, so that the seeker can be locked on to the flare rather than the aircraft. And once it is locked on onto the flare, then the aircraft can maneuver and get out of the way. Normally, the lower temperature at which one of the composition is working is higher than the heat of the incoming flare is also the design for the range of frequency. The first range is between 2 to 3 micrometers and as designed as alpha. And it is called as alpha. And the second range is between 4 to 5 micrometers and it is called as beta. In case the spectral flare is the second type of flares which are used for the modern time seekers which are which are operating at 2 different frequencies. The spectral flare produced a high intensity compared to the aircraft or and the ratio between alpha and beta is called theta. Normally, the theta which is used in the seekers ranges from 0.26 to 0.7. The higher component like the aircraft body emits alpha and then engine exhaust emits in a combination of alpha and beta. The theta value of the aircraft are between 0.26 to 0.7. So the decoy flare or the flare which has been used to deceive the seeker has to work on, normally they work between 0.5 to 0.7 ratio between alpha and beta. The total misguide on the coming missile and from the aircraft. The decoy flare formulation mainly consists of oxidizer, metal fuel, and binder. The oxidizers here are zirconium powder or boron powder, titanium powder, aluminum powder, potassium benzoate, and magnesium. The commonly used oxidizers are potassium chloride, potassium nitrate, Teflon, or a binder. And the binder is normally a Viton, which is about 5% or so, which acts as a binder cum fuel. The spectral flares are basically based on combination of MTV and the burning composition, which consisting of potassium benzoate, potassium chlorate, and Viton. The burn rate and the particle size are so chosen that the spectral flare burns, not only burns, but it burns for a longer period so that the incoming missile is sort of misguided and the aircraft can maneuver and can get out of the way of the incoming missile. So there's a lot of work which has been done on the flares as well as on the seekers, so that one is little ahead and the second one catches up. And there is a competition going on between the seekers and the type of flares which are used to defeat them. We are making presently the MTV type, and we have developed our own flares for this thing, spectral type, but we have got a repeat order for the MTV, and we are waiting for the inquiry to come in for spectral flare. Once the inquiry comes, then we will inquire, but many a time, the Atmanirbhar Bharat scheme or vocal for local is defeated by the RFI being floated and then withdrawn after months together. And 2-3 times it happened, so that, we are discouraged by this process. But we hope that it will stabilize and local will be given preference over the imported material. I thank the MC and the management of ISRO to have given us a chance to speak on this particular webinar. Thank you, ma'am.
Thank you for the beautiful talk and sharing the experience of your journey with us today, sir. Now, let us have the next talk by Sri Rohan M. Ganapati. I request Sri Gokul, Member Organizing Committee, to introduce Sri Rohan M. Ganapati to the gathering. Gokul, are you available?
Can you hear, ma'am?
Yeah.
Yeah, fine. Okay. Can you hear me, ma'am?
Continue. We
Yeah,
could able
thank
to
you.
hear you.
Yes. So I think we had last time the Srinath, who's from Agnikul CEO, could able to address the younger community for the entrepreneurship and the startup of the rocket. I think today we have another a very versatile and young speaker, Rohan M. Ganapati. I think he's the one initiator of the Bellatrix, and they already captured a good amount of business with ISRO. Also, I think they are giving some electric propulsion system to satellite. So it's very indeed to welcome Rohan Ganapati to this webinar 02, which is organized from MC Shah Chennai and also like ISRO. To brief about, I think Rohan M. Ganapati is a CEO and CTO of Bellatrix Aerospace, new space company which is incorporated in 2015, involved in indigenous development and manufacturer of advanced in-space propulsion system. He is an aeronautical engineer and his area of work include propulsion, electric propulsion, rocket propulsion, and space system engineering. Rohan developed and patented the microwave plasma thruster, an advanced type of electric propulsion system that runs on water as propellant and offers various advantages compared to existing technologies. He was also featured uh, in the Forbes 30 under 30 list for India and Asia in 2018. Rohan was selected a part of Club Young Leader 2020 by the government of France and was also listed on the Deccan Herald Changemakers 2020 list. Bellatrix Aerospace has also supplied microwave plasma thruster to ISRO for their application. Bellatrix was awarded the TDB National Award 2017 from the Honourable President of India for the development of technology with potential for commercialization. Bellatrix has raised almost $3 million in funding from Indian investor to support space qualification of its propulsion system. In 2020, Bellatrix won National Startup Award at ET Best on Campus Award and also listed in the ET India Top 20. With this, a small short introduction, may I welcome our Rohan Ganapati. Definitely, I think he is going to give up how the initiation is with ISRO. Also, how the journey is going to be established in the near future. It's over to Rohan. You can take up. Thank you.
Thank you, sir, for your warm introduction. Gentlemen and ladies, good evening. Thank you for having me on board today for this discussion. Of course, I'm nobody when compared to all the members who just spoke. Their experience, everything is just an inspiration for us. Been following even the works of Dr. A.N. Gupta at Premier Explosives. The work they have done at indigenizing this is very critical, because we are, before I start my presentation, I'd just like to add how important high energy materials are for the country. Because see, everything falls under, if you are from US, it falls under ITAR. If India was not a signatory to MTCR, Missile Technology Control Regime, until recently. So there was a lot of, it hosts a lot of problems for us to import such technologies where indigenization is the key. And I'm very happy that we are in the era where our elders have created the path for us to continue. So I'll just give a short presentation about what we are doing here at Bellatrix. So I have a small PPT. Kindly confirm if this is visible to you. Yes.
Yeah, it's visible.
Thank you for the confirmation. So We are an aerospace propulsion systems company, primarily working on developing in-space propulsion. The difference between normal propulsion, normal rocket propulsion and in-space propulsion is that we develop engines which only work once the satellite reaches orbit, once the satellite is injected into its orbit. So we take care of movement in space, where efficiency, everything is the key. So we, as a company, started working from the year 2015 at IISc Bangalore, and we specialize mainly in electric propulsion and chemical propulsion, which I will be talking about. And we have developed and qualified propulsion systems for nano satellites, which are in the 1 to 10 kilogram category, all the way up to 5-ton class of satellites, the huge communication satellites. So, and I'm also proud to say that we were the first startup to be recognized by ISRO and giving a hand holding by ISRO to support us in this particular technology development. With that, as I said, we work on these classes of satellites. For larger satellites, as you can see on the slide, we have something called as microwave plasma thrusters. We have, we use a special type of water. Basically, it's an ionic liquid, which we convert into a state of plasma and accelerate it to give you thrust. Then we have green monopropellant thrusters, which I'll be talking about. This comes under chemical propulsion. So under this technology, green monopropellant thrusters, we have scaled it down to a 1 centimeter chip all the way up to thrusters for larger satellites, which can give you up to 100 newtons of thrust. And in electric propulsion, as I said, we work on microwave plasma and Hall effect thrusters. So we in India, we work closely with ISRO and DRDO. ISRO primarily with electric propulsion and DRDO with chemical propulsion. And as I'll just skip this slide, as Gokul has mentioned, we have been recognized pretty well by the government for our work. And this is one particular thing which our former chairman of ISRO, was happy to tell about, that they have given us a contract which they themselves have not developed. So in a contrast, this actually helped others also perceive that they were of the view that ISRO is not supportive to startups, but in fact they are. So our own experience states that with ISRO, if you have developed a very good technology and when you are actually collaborating from a collaborative point of view, they will definitely support you. That was our case, and we have recently supplied that particular technology. When we talk, if you ask me what is electric propulsion, it is different than what you see at cars or automobiles, basically. So it is very different. So instead of chemical combustion, basically what happens in a chemical combustion is you are taking the energy content of a molecule, you're extracting it. In electric propulsion, it's the other way. You're giving it electric energy to get some thrust out of it. So the advantage with this is it gives you a more mileage or specific impulse, as we call. So we talk a rocket engine, for example, a liquid propellant rocket gives you a specific impulse of somewhere from 250 all the way up to 400 seconds. Seconds being the unit. In electric propulsion, we start at around 1000 seconds of specific impulse. So that means when you design a satellite, you have more space for your payload rather than the propellant or the propulsion systems itself. So I think everybody is aware the cost of going to space is very high. How you can cut down is by looking at these technologies. Now, of course, these were only developed by advanced countries like Russia and the US, but now we are also in a position to give better, if not competing technology in this particular field. And one example, if you look at chemical propulsion satellites, if it's a 3.5 ton communication satellite, you only have 0.5 ton space for a useful payload. This is just an average. 2 tons is just fuel, but if you shift it to electric propulsion, you can increase the space available for payload. So in simple terms, space is going all electric, but why do we still require chemical? I'll also come to the point. So before I go there, I would like to tell the importance of high energy materials and chemical engineering, which is critical in the field of space propulsion. So unlike aircraft engines, rocket engines are more complex. The propellant handling, everything is very expensive. If you have to set up a propellant processing unit, and the cost involved, the storage characteristics, everything is expensive. Of course, what we started looking, what particular problem we wanted to address is with that of replacing hydrazine as a liquid propellant in satellites or the upper stage engines by developing a greener alternative to it. So we wanted a propellant which has higher oxygen balance and which can release more energy, and at the same time its exhaust products are not toxic or non-carcinogenic. And we wanted it to be safely storable, because storability and handling is critical when it comes to high energy materials. So that led to the research where we successfully developed and patented a green propellant called, we have two types of green propellants. One is hydroxyl ammonium nitrate based green propellant, which we are presently working with DRDO in qualifying it. The advantage with this particular blend, as we call is, the decomposing product is basically water. You get more than 60% of the decomposition products are water. You need not fill the satellite. You can fill the satellite at your, for example, if the satellite comes from URSC here in Bangalore and to Sriharikota, the filling of the propellant is done at Sriharikota. But here in this case with this propellant, because it is not sensitive to shock, we can actually fill it at the location where the satellite is manufactured, and you can ship it to launch. It is safe to carry on board an airplane, and it doesn't have cold start capability, as I call. That means if it comes in contact with a catalyst, basically a monopropellant has both oxidizer and fuel in it, and it undergoes catalytic decomposition when you send it across a catalyst. In our case, to increase the safety of it, if at all there is a leak, so we have ensured that unless and until a specific temperature it is heated, the propellant will not decompose, which basically looking at replacing hydrazine, which is even though proven technology, when private people start to enter to space, cost is a major factor to bring down. This was a critical innovation which had to be done in-house. So we have set up a complete in-space propulsion laboratory at the Indian Institute of Science here in Bangalore, where we manufacture, we test, and we qualify propulsion systems, both electric and chemical. You can see one of the engines which we have delivered to ISRO. This is an electric propulsion system which uses an ionic water as a propellant. You can see the exhaust coming out of it. Water is exciting because it's much denser, so you get a little higher thrust. And we are not, as people would assume, we are not taking the hydrogen and the oxygen out and then giving combustion. Instead, what we do is the water vapor is directly converted to a state of plasma to get a higher specific impulse. This is something we have done. And of course, it has other advantages in terms of cost and weight comparison, which you can see in this slide. Particularly what I would like to tell is, even though this is a little off topic with today's discussion, the importance of chemical engineering in the field of rocket propulsion is very huge. Without understanding how they behave, it is not something that we as aerospace engineers can do. So we started the company as 4 aeronautical engineers, and slowly now we have a team. We are 35 people team now, and majority of them have a chemical or a chemistry background to deal in this particular space. And how this particular energetic propellant enabled us to even scale down the propulsion systems. So in space propulsion systems, we talk about scaling law. So if you develop any technology, it scales well when you actually scale it up, but it doesn't scale well down when you want to downsize it. So there are a lot of challenges. And these days, as you're aware, the MEMS-based technology and the electronics are becoming so small that what a bigger satellite was able to do, now smaller satellites are able to do. The only problem with small satellites are that they do not have sufficient space for propulsion systems, and they normally fly without propulsion systems. So which made us rethink if the green propellant which we have developed to replace hydrazine can be used on a smaller scale, where we have again collaborated with ISRO and ISC, SCL Chandigarh to come out with more MEMS-based technologies where propulsion systems can be miniaturized. We are currently trying to, this is a liquid propellant which we have developed. We are currently trying to make it into a solid as well, because it will become a greener solid propellant. So for this, we are working with DRDO. Basically, it's not fully solid. We call it as a thixotrope. It's just, imagine the propellant like a tomato sauce, a tomato ketchup. If you put it in a glass of, for example, a glass or a glass tumbler, and if you invert it, it doesn't fall unless you apply some shear to it. So it's a shear thinning liquid which we are doing. So for potential rocket propulsion applications, where it has the advantage of long storability, it doesn't form cracks, and it doesn't form small pores which act as miniature combustion chambers, and it has a better combustion efficiency, and aiming at a sea level specific impulse of around 300 seconds, which is very exciting domain in the field of solid propulsion. I would like to extend our invitation to people in this today's conference, that whenever they visit Bangalore or IISc in particular, feel free to come and look at the technology which we are doing here. So that being said, the slides which are prepared are a little, out of topic. But what I would like to talk is, of course, the applications of satellites. But where I have to come is, for example, what is happening in the private space industry worldwide, which is very critical. So I would call, even though a private ecosystem existed, there was never a boost. They were all defense contractors. So there was always B2G kind of industry setup, particularly in aerospace propulsion. So now what is happening is, with the advent of SpaceX and other players around the globe, there's also demand for private to private people. For example, now with new law in space, which has been recently announced even by our country. So even a private person can launch a satellite and give services to the ground station. So we divide space into two categories, the upstream and the downstream. So companies like us develop technologies for the upstream, which work in space. Downstream is people who use the data which is generated by the technologies from the upstream companies. So this catalyst happened when SpaceX won the contract from NASA to launch commercial payloads to orbit. And now recently, even ISRO has come forward to involve private people more into R&D area, R&D development in this particular area. And I was just talking to even Gokul. Our own experience is that before all this happened, we were with ISRO. If you look at the Indian scenario, if you have any compelling technology, ISRO or DRDO will always come forward to kind of support it and help you qualify, because we are all youngsters. One thing which we lack is experience. And that in our case, our advice which we got from working with ISRO helped us to understand how things can work in space. Because I know people, you can understand dealing with a propellant is not an easy thing, or developing something which has to work in space for 10 to 15 years without failure. You have to imagine the amount of quality and checks which go into it. It's a difficult industry with a lot of, it's very capital intensive. But we have to invest in research and development with support from government and private institutions, so that we can meet the goal of Atmanirbhar Bharat. So these are few of the emerging launch service providers which are also coming. Even rocketry is going private. In India, you have 3 companies now. This is an older slide. You have Agnikul and Skyroot, who are developing solid propellant and liquid propellant rockets. And we, Bellatrix, now we mainly look at developing the R&D behind propulsion systems. You can look worldwide. What is happening is, in the advent of small satellites, there are demand for dedicated small satellite launch vehicles, where it is a combination of liquid and solid propellants. And because you don't have the luxury of waiting long to piggyback on a longer rocket, a larger rocket. So that's why there's a good business potential for small satellite launch vehicles. with a payload of maximum of up to 500 kilograms, where there is a lot of potential for us to increase its performance in terms of solid propellant chemistry as well as innovative liquid engines. Now we are all looking at going away with kerosene as the fuel. We are looking at methane as more greener and more energetic form of liquid propellant. And a lot of research has been going on in this particular area. And as Sir was mentioning, Premier has a good experience when it comes to with ISRO, of course, in casting solid rocket propellants. To cross the Earth's atmosphere, a lot of energy by the rocket initially has to be spent by overcoming the atmospheric drag. So if you look at what is happening worldwide, is they're coming with some special formulations of solid propellant itself, where the rocket can be much smaller, the stages can be much smaller, and yet not sacrifice on the payload capacity, and it can be launched through an airplane where the atmosphere is thinner, say at around 11 to 14 kilometers above the sea level. Such technologies are also being worked on. Best example is Richard Branson's Virgin Orbit or Virgin Galactic, where they're working on such technologies. And they have there's also hybrid rocket motors, which is of greater interest, where your fuel is a solid, for example, like any kind of a rubber, and your oxidizer being hydrogen peroxide. So one thing in the country which we lack is when we set out developing this propellant, I mean, building a team which has expertise in high energy materials or has handled it was pretty difficult. So we had to look at advisors from inside ISRO and DRDO, and also from Shell, companies like Shell who have worked there, and other parts of the country. And with their help, we were able to do it. So I think this is a good platform for us to suggest through the High Energy Materials Research Institute, HEMSI. What I would like to propose is we can also come up with, for example, at the BTech chemical engineering level, a chapter or a study material which also says about the importance of high energy materials in the field of propulsion, so that people are aware, and we also develop the base which we require to hire. And yes, that has been our journey so far. We are looking at qualifying the propulsion system next year through Indian as well as foreign launches. And I'm happy to say we are contributing towards the goal of Atmanirbharta. And in this critical technology, even though it's just a small part of a bigger system called as propulsion systems. Thank you for having me this evening. And if there are any questions, we can always discuss. Thank you so much.
Yeah, thank you, Rohan. Since we are in the high energy materials field, as you told, age and experience had not stopped you to explore today, Rohan. Since we know very well, milligrams of initiation is sufficient to explore the whole rocket propulsion system. You would have initiated many minds today to explore the in the aerospace field. Thank you
Thank you for it. I would just like to mention, just because even some few students are here, the dangers of it. I myself had to undergo plastic surgery on my hands when we were playing with amateur rocket fuel, like potassium nitrate and sugar. Even that itself is pretty, it undergoes I mean, explosion when if not handled carefully. So even students, whoever wants to build a rocket, just because rockets are very, very inspiring, please be careful.
Yeah, thank you for your caution also, Rohan. With this, we have come to an end of the expert talk session. We can now we can go for the question answer session. If any of the participants would like to ask any of the speaker, please you can clarify your doubts. It's open to you.
Guptaji, I have a question. I'm Shaktivel here. Guptaji is available. Hello.
Yes, sir is available. Sir is unmute, I think.
Guptaji, can you hear me?
No, sir has to unmute, sir. I think sir can hear you. Yeah, now
Okay.
sir can talk. Yes, sir.
I can hear you.
Yeah, Guptaji, you explained about the various kinds of metals which are used in creating flares. And what basis the metals are chosen? Is it based on the reflectance value, which will be helpful for acquiring those reflectance by using the radar, or because of the potential to act as an oxidant, or which is taking the primary characteristics are utilized for this?
So your actually voice is not very clear here, but what I could understand is that on what basis do we select the metal for the seeker, for the flares? When you see, we go only by their frequency and the temperature it creates. It can be aluminum, it could be zircon, or it could be, but when the cost comes in picture, the magnesium seems to be the best material because it can produce very high quality heat and it is cheaply available and it is available everywhere.
Yes, sir. Thank you, sir. I think, sir, Shaktivel says it okay. Like,
yeah, it's okay. Not based on the reflectance value.
Sir?
Okay, got it.
Yes, sir, he got it, sir. Gupta, sir, I think he got your answer. Thank you, sir. Is there any other QA is there, like from any of our members as well as the audience who's there inside? To both of them, I think, to Gupta sir as well as with Rohan. Maybe.
Someone is unmuted. Gunashekaran sir, do you want to ask any question?
Yeah, we can ask our, maybe Kannada sir is there, ma'am, so that we can ask her to talk.
Okay, if no more questions are there, we'll close the question answer session here. In case if you have any further questions, please drop a message in the comment box. We will get back to you with the answers at the earliest. Now I request. Hello.
Yes, ma'am. Yes.
You could able to hear. Now I request Chairman MC Sharchane Chapter Sri V. Ranganathan sir to say a few words regarding today's session.
Ma'am, there is some a few questions. Yeah, ma'am.
What, Gokul?
Yeah, few questions have come from our YouTube.
Okay, you can convey the questions
Yeah.
to the
Yes, sir. One from I think Santosh Gopal Krishnan I've asked to Rohan. Maybe I think not. It's a Sivamani. What is the present status of electric propulsion in our country?
Well, electric propulsion was initiated by ISRO in the year 2003. They have come a long way. It's a big project inside ISRO. And they have actually qualified major elements of it. And you could see one of the major propulsion systems even coming, going to space pretty soon. As far as looking at the private ecosystem, we took the plunge and we are the only companies working on electric propulsion currently in the country. It's a long gestation period which is required to initiate this technology. An amalgamation of many fields. So, but what I would say is what ISRO has developed in the electric propulsion field and what we are doing, I can happily say that we are presently at least on par with whatever is available around the globe in this particular field of electric. Hope that answers it.
Yeah. I think there is more applause from many people about this presentation for both of speaker. And also, I think one speaker you want to ask, but he has not. He could not able to give his query. He's a maybe Santosh Gopalakrishnan wanted. I think he can give us questions here. And Vikram was asked, what is the catalyst used? Is there any catalyst is used here?
So of course, catalysts are used. Every catalyst is fine-tuned for your particular propellant which you are using. But basically, for hydrazine, you use iridium as a catalyst. If you have hydrogen peroxide, you use as a catalyst. Platinum group of materials. So of course, there are other catalysts we are working on, but these are the common.
I have a question to Pradeep.
Okay, there is another from Santosh Gopalakrishnan. What is the combustion temperature achieved in your monopropellant? Do you have high temperature thrust chamber in development?
It's a good question. Any high energy
Yes,
materials?
sir. Just a minute. Our chairman wants to tell something. Sir, please, sir. Hello. Ranganathan, sir, do you want to tell something? Rohan, you can go ahead. I think some interruption.
Okay, that's okay. So that's what, as I was saying, with any high energy materials, right? You cannot allow it to give out its complete energy to you. That would be catastrophic. So you also have to control. There's always limitation on metallurgy. There's no. I'm sorry.
Yes, sir.
Can I continue?
Please continue, Rohan.
Okay. So as I was saying, there's no limitation on the propellant as such. The limitation comes from the metallurgy of it. There's no metal which can withstand a larger temperature without being cooled. So we are looking, the normal hydrazine thrusters experience a temperature of a combustion temperature of about 1000 degrees Celsius. We are looking at about 1800 degrees Celsius, which of course has resulted in a better performance. Of course, high thrust engines are being designed in-house. We are doing up to 100 Newton as such. But please keep in mind, these are in-space propulsion systems and we don't generate kilonewtons of thrust as you would require on any of the missile or a ground-based approach.
Yes, that's all. These are the questions which were asked in YouTube. It's over to Sangeeta. Ma'am, you can proceed.
Yeah, thank you, Gokul. Sir, this is the time for taking feedback from our valuable chief guest as well as from the chairman of the HEMC and vice chairman.
There's one question comes from Vamsi, ma'am.
Yeah, you
Chat
go
box.
ahead. Yeah, you go ahead.
Will scramjet techniques in near future can be useful in orbit insertion?
If you're aware, ISRO is also working on this technology that is taking oxygen from the Earth's atmosphere, where you only carry the fuel with you. And once you use that oxygen available in the Earth's atmosphere and fill up your tanks in the scramjet mode, then the engine will be converted to as a rocket engine, and then you can go to orbit. This is a technology in development. And of course, it has its own advantages. So these are called single stage to orbit vehicles, SSTOs.
Any more questions, Gokul?
That's all, ma'am. In chat box it is. That's
Okay. Thank you. I think many more questions may come for our youngster Rohan. We'll forward the questions to you. You can clarify because since it is a students forum, they may think and come back to you. So please ready for answering everyone's question. Now I request Shri V. Ranganathan, Chairman MC, Sharchane chapter to say a few words about this session. Sir, Ranganathan sir? Sir is available?
Yeah, sir is available.
Okay, again, good evening all of you. Yeah, are you able to hear me?
Yes, sir, we can
hear
hear.
me?
Yeah, sir. We are hearing somewhat breaking, sir. Voice is breaking. Yeah, we are hearing you, sir.
Hello. Okay. Good evening, all of you. Okay, then they can put in the junction, and first I should thank Dr. Ajay and our Rohan Ganpati. Today, whether it has happened so or otherwise, we could be able to see the capability.
Sir, you're breaking. You can close it.
We are up to the high-tech area. Okay, now it's okay?
Yeah, now it is perfect, sir. I think because of video, I think it is breaking up. Now it is perfect, sir.
Hello?
Now it is perfect, sir. You can proceed, sir.
Okay. It so happened that.
Please go ahead. Sir, please go ahead.
Both the speakers today, who have participated in, because of talking about high-tech, where there's an unconventional propulsion system, where one of the Indian industries, namely Premier Explosives, is capable of doing conventional warfare. I was talking about again high-tech propulsion and beyond. So happy that this our chapter is able to conduct. I'm happy, and I look forward to such a webinar, so that at this pandemic time, I think this is a very good way of conducting seminars and disseminating various technical aspects among our chapters. So with this, I'll thank all of you.
Thank you for the opportunity.
And all the people who contributed for this. Then host Guptaji, thank you.
Thank you
and
very
Rohan,
much, sir.
Thank you very much.
To meet you all.
It was our pleasure.
Thank you, sir. Thank you, sir. Now I request Shri P. Kanagaraju, Vice Chairman, MC. Yeah, sir. Please continue, sir. Sorry.
Mine is over.
Yeah. Thank you, sir.
Go ahead.
Yeah, thank you, sir. Now I request P. Kanagaraju, Vice Chairman, MC Sharchani chapter, to express his views. Kanagaraju, sir?
Yeah. Thank you, madam. I think I am audible to all the people, and you are able to see me also.
Yes, sir.
Yeah. When we are thinking about this webinar, I have another responsibility as a president of Indian Institute of Chemical Engineers to amalgamate the space chemistry chemical engineers and general chemical engineers, and especially the students who are looking at rocketry. Many requests are coming to me for projects and internships. So this shows that even chemical engineers are interested in ISRO, not only because ISRO is a pride to the nation, but also that there are good job opportunities. There is a lot of scope for research, and nowadays many universities are asking for research papers to enter into MS or MSc or whatever. So in this context, we thought exposing the space chemical engineering to general chemical engineering is one of the necessities for the nation. So in this context, we want to have many webinars like this, series 3, 4, 5, 6, where both IACH and MC will come together. So today, for me as a president and here and vice president there, I have a lot of concern how this is going to be taken up and how it is going to be, how people will take up. And it is an experiment for me, and I'm in tension from past 1 hour. I'm just looking at both Dr. Gupta and Mr. Rohan, whether they will give something else or what I want, whether my experiment is correct or not. And indeed, my experiment is correct. This is what exactly we want, and this is what we got. So if customer satisfaction is the quality slogan, we achieved it. I think the customers are satisfied, and they could get something out of both of you. If some project, if some student is asking, I want to work on flares, I think that credit goes to Dr. Gupta. And if somebody wants to ask for a job in your company, Valedictories, I think you are the successful guy. So good that your lectures are very common. You used a simple, easy language so that around 250 students are listening. That is what I understood. So they are benefited, and on the other side also, as a space chemical engineer, I also got benefited. I have flares. Our library is having a book on the flares, but I don't think anybody has taken that book. So at least in the next 1 week, people will go and open that book. I have seen once, and last year I asked one of the professor to give a lecture on Deepavali materials, flares, incendiaries, etc., etc. But I could not get a person. Today I have seen Dr. Gupta as the person whom I want. Similarly, Rohan, I thank you for your nice words and your lecture on your imaginative things in space, which we are thinking earlier is an imagination. Today, you are putting money. That means you are making it more and more practicable thing. Okay, what we are thinking about 20 years back, taking an aeroplane, go to space is easier than start right from the ground. Is an imagination of an average space rocket designer, and you could do it. I mean, today you are investing money to make it possible. So I appreciate you. Even I look for a job for you with you. Okay, to that extent you inspired me. Nice. And we have some ideas like Zeppelin, which is a huge balloon, and it can take. You might have heard about it. It took about 1,000 people once upon a time in 1910 and 1920. So whatever you are talking about payloads, maybe that is the thing. Humans may be difficult for Zeppelin. Today still the Zeppelin institution in Germany is still active. Maybe you can pursue. Okay, these velocities and controllability and access controllability are very benign. You can think about it. Anyway, it is both the lectures are good for me as a personal thing, to my colleagues at SHAR, and to the people who are listening to both of you in general. I am very thankful to you. Thank you, madam.
Thank you, sir. Thank you so much, sir. I think network problem has not stopped in any of our imagination. Still, we are able to imagine to the extent possible. It is not stopping us. So now I request Shri Shaktivel sir, General Secretary, HEMSE SHAR Chennai chapter, to give a vote of thanks.
Yeah. Good evening, all of you. I take this privilege to be part of this lecture program and also to propose vote of thanks. First and foremost, I thank our beloved Chairman Sri Ranganathan sir for his continuous encouragement and guidance in organizing webinar 2 in spite of his busy schedule. I express my gratitude and thanks to Sri Kanaraj sir for his motivation in arranging this lecture session. My heartfelt sincere thanks to Dr. A.N. Guptaji, whose lecture on flares for use as a countermeasure in defense is very informative and interesting. His rich knowledge in defense systems would surely motivate and encourage student community to understand the techniques in the field of defense. And the materials, various materials, oxidizers and fuels what are used as part of the flares and its characters was explained so well. Thanks are due to Sri Rohan M. Ganapati for his lecture on in-space propulsion, a journey with ISRO, that described various propulsion systems are in use and demand as well as the requirements for future. Plasma thrust, then green monopropellant thrust, nano propulsion thrust, then electric propulsion thrust. Sir, you explained so well. And we have got really very good knowledge about the electric propulsions and the way how it can bring down the launch cost. And coming to green propellant, how we can safeguard our environment and how we can safeguard our ecosystems, all kind of us explained very nicely. Very big thanks to students community in joining this program and showing interest in acquiring knowledge for know-how through this lecture session. I also thank the organizers who have worked hard in realizing this webinar 2 session today for the benefit of students and the technical community. Once again, thank you, one and all.
Yes.
Thank you, sir. I hope every audience would have enjoyed today's session. Now it's time to all of us to stand for our national.
Ma'am, one, I think we have already given our feedback form both in YouTube as well as in the chat box. The students and other participants to avail the certificate, they can fill the feedback form and submit it to us. So that within 10 days, the certificates will be received to you. For this
Sangeeta, can I ask Raju to speak a word?
Yes, sir, you can have, sir.
Rajiv is there. Rajiv Singh.
Raju is not there, sir.
Okay. Okay, continue. You continue, madam.
Okay, sir. Okay. Thank you, one and all. And let us stand for the national anthem.
Balamurgan, national anthem, yeah.
Punjab Sindhu Dravida Uttala Vanga Vindhya Himachala Yamuna Uttala Jaladi Taranga
So thank you. I think I'll just close the YouTube so that then we can